Welcome to the next lecture on mechanical and electrical systems of mining machines. So, coming to the lecture number 2, where we continue with the overview on the mining machines. So, in last class, we were discussing about the specification of mining machines. We started with excavator, where we discussed about how do we specify the excavator with bucket capacity and boom length. We discussed again about the bucket capacity are of two types, that is a struck capacity and that is a hip capacity. Then we discussed about the specifications of dumpers, belt conveyors, dozers, graders and drilling machines, and we also discussed why we define the specification of dumper in maximum weight of the material, not in cubic meter, not in volume, but in weight. Now coming to the shapes and sizes of the mining machines. When we see the small machines, like what do we categorize as small machines? So when we see a dozer, a pea loader or a scraper, we classify them under as small machines. And how small they are? They are as high as a one-story building and they occupy 30 square meter ground area. However, when we see a bucket wheel excavator, they are as high as a 5-story building and they occupy 200 square meter ground area. However, when we see for a drag line, when its boom is lifted, the height reaches a 30-story building, that is 96 meter, and when laid horizontally, it is as long as the length of the bridge over a small river. And the bucket size is so big that it can accommodate 2 motor cars simultaneously. And the drag line, when it stands on a ground, it would occupy a space of 650 square meter. Now, while talking about the different excavators operation, when we see a shovel or specifically a backhoe in this case, so there are certain operations like crowding or digging operation. So you can see here a shovel is crowding onto a loose soil. It can be also a hard rock where it is crowding onto and doing the excavating operation. So this operation we call it as a crowding or digging operation. Now hoisting and lifting operation, if you see, there can be of two types. One is a boom hoist and one can be a bucket hoist. One is a boom hoist and other can be a bucket hoist. So if we see here, this is the shovel. So if it moves the boom up and down, we call it as a boom hoist, and similarly if it would move the bucket up and down, we call it as a bucket hoist. The swinging or revolving action, you can see here for a bucket wheel excavator, where it is doing the swinging or revolving action and it is making a cut for the total trench. Now when we talk about the traveling or marching operation, so it is the forward or backward movement of any heavy machinery. It may be through a crawler or through tires as well. Now the operations by other machineries, it can be the transport equipment operation where the dumper or the belt conveyor carry the material from one point and dumps it at another point. It is an intermittent discharge type transport equipment, and the belt conveyor is a continuous discharge type transport equipment where it continuously carries the material from one point to the other. Then we have the road making and maintenance operations, which are generally done by dozer or graders. I have already discussed about their operations. And then we have this drilling machine operations, which make holes at predetermined location. Now there are certain terminologies that will be used during the entire course, that is bank or loose. So what do we call it as a bank? It refers to the weight or volume of material as it was in its natural or undisturbed condition. So you see here the soil or the rock is in bank, it is in virgin state, it is not disturbed. We also call it as a unconsolidated, if it is a soil we call it as a unconsolidated soil or rock. When we refer to the word loose, it refers to loose volume or weight, and it indicates disturbed state of the rock. So if you see this loose soil or rock, it is already disturbed from its uh, unconsolidated state. So we tell it as a consolidated soil or rock. Now there is a term called as a fill factor. So there is a term which we call it as a fill factor. Now what is a fill factor? It is a measure of the degree or fraction of bucket filling during excavation. So it indicates the void space inside the bucket when it is filled up during excavation. So, and it depends of various factors. So one of the factor is the particle size or fragmentation size. Let me give you an example. Let's say you have a tub which is filled up with sand or water. Let's say we take it as sand, and we have a jar which we try to put it onto the sand and fill it out in one go. So now the amount of material that gets filled into the jar, we call it as the fill factor of the jar. So the jar must be having certain inner volume, which we call it as its struck capacity, and the amount of material that gets filled inside the jar, we call it as like that has certain volume. So that volume divided by the total volume of the jar gives us the fill factor. It may be certain percentage, and it completely depends on the particle size. Let's say instead of sand you have rock, so the fill factor will definitely reduce. Now it also depends on the type of material handled, like if we fill sand or rock, so again your fill factor will vary. And this type of material, let's say if it is rock and it has different particle size, there also your fill factor will vary. Again, the third factor on which the onto which your fill factor is dependent on is the difficulty the bucket has to face in penetrating the material. Let's say there is a virgin face of the rock onto which this excavator, the bucket of the excavator has to penetrate onto. Let's say if it is a soft ore body, then the penetration would be easier and the fill factor will be more. However, if the ore body is hard, then the penetration, there will be difficulty in penetration and the fill factor will be less. So which explains the fourth factor, that is the penetrating or the crowding force with which the bucket is forced against the material. Now let us say there is one kind of rock of certain strength or and then this bucket is tried to crowd onto this face of the ore body. So the force with which the crowding action takes place also affects your fill factor. So when we mathematically express it, our fill factor is the ratio of the volume of the material accepted by the bucket at its maximum by the inside volume of the bucket, that is V2 by V1. When we see the fill factor of bucket will excavator, it is around 85% due to better penetration and improved bucket design. However, for dragline it is around 65% due to difficulty in penetration, and in shovel the fill factor is around 75%. Now, when we talk about swell factor, what is this swell factor? One, we understood what is fill factor, and the second terminology is the swell factor. So, what is the swell factor? Let's say there is, if we see there is this rock in its natural condition. So, we see that it is of 1 cubic yard that is in place. However, when we excavate it by using a shovel and dump it onto a dump truck, its volume increases. That is, there is a swelling of this material, which is 1.25 cubic yard. So, this we call it as the swell factor. So, it is the ratio of the volume of the material measured in the disturbed or loose state to the volume of the material in its undisturbed state. So, with this, we understand our swell factor will be more than 1. And when this material we put it onto a ground where we would compact it using a roller, so with the compaction its volume decreases to 0.9 cubic yard. So, this does not signify the fill factor. However, it signifies that in natural condition the material may not be well compacted, which when compacted by an external force can also reduce the volume. Now, we have covered different terminologies, specifications, shape sizes, and we have also understood different operations for surface mining machines. Now, coming to an overview of the underground mining machines. So, when we talk about underground mining machines, it deals with the opening up of an incline or vertical access road or shafts which is below the ground surface. Now, the various operations that deals with underground mining is the ground breaking, loading, transportation and strata supporting jobs. So, for all the various operations, we have different machines that cater to these operations. Like we have drills, coal cutting machines, road heading machines or winding machines like continuous miners or shearers, which does the ground breaking operation. So, if you see this picture here, it is we call it as a shearer, where you can see they have two ranging arms, one this side and the other on that side, and we have the cutter heads over the ranging arms. So, this specifically, this kind of machine, they are used in longwall mining. However, when we see this kind of machine, which we call it as the continuous miner, these are the new technology machines. This is being used in board and pillar mining method. We have few of the loading and transport machineries like side discharge loader, shuttle cars or load haul dumper. So, if you see this machine, this is tire mounted. So, we call this as the load haul dumper. These are very small and compact in size so that they can work in any thickness of the seam in the underground mining operations. However, if you see this machine, we call it as a side discharge loader, which is crawler mounted, which gives us the benefit of doing the transporting operation in higher gradient, and it would discharge sideways. So, that's why its name come as a side discharge loader. We also have strata supporting machines and dewatering machineries, which we call it as the pumps. So, for strata supporting machines, we have different kinds. We have roof bolters, which would help us in putting up the roof bolts for the supporting of the strata, or we have movable mechanical supports or packing machines which would support the strata. Now, the characteristics of this underground mining machines, what we want to see is the high horsepower motor, built-in microprocessor technology, environmental and safety features, or the application of automation and remote control, which is very much necessary in today's era. It is also very much important that these underground mining machines adapt with varying geomining conditions. So one thing that we must be very much clear that, let's say, a machine which works well for any other country or any other mines may not be very much suitable for the mines for which we are intending to apply it to. So we have to have a thorough geomining assessment, or the geophysical and mechanical assessment of the geology, so that we can do a proper mine equipment selection. It should also have a modular construction for easy dismantling and reinstallation, as it has to go through the vertical shaft where it has to be assembled there. As these machines are quite huge, they cannot be just taken in one piece to the underground environment. Now, we can like there is another class of machinery which we call it as a high wall mining machines, which are specifically used for high wall mining. So what do we understand by high wall mining? Let's say there is a cliff and there is a ore body which is trapped inside under the cliff. So we can use such a machinery, which we call it as a high wall mining machines, to take out the ore body. So what is the requirement of this high wall mining? It should be there should be automatic control and remote operation. It should be a manless operation. Due to restricted height, the machine should be designed in certain way that it can operate in restricted height. It should be robust but highly maneuverable. The capability to work on unventilated phase, and the easy to recover if trapped under collapsed roof. So when we talk about the capability to work on unventilated phase, we understand that there is no human operation, it is only machine operation. Now when we see the main elements of this high wall mining machines, so here we see there is a continuous miner. Continuous miner means there is a cutter head which is continuously cutting onto the ore body. There is number of conveyor cars, that is the add cars. You can see there is a stack here which pushes onto the number of conveyor cars that is required to take out the ore body that is being cut by this continuous miner. Then there is a launch vehicle. So you can see there is a launch vehicle which is stationed outside the cliff. There is a elevating stacker conveyor, and there is a wheel loader with a forklift attachment. So it is the wheel loader with forklifter is you cannot see here. So this is the wheel loader, and the forklifter it's somewhere here. Now the characteristics of high wall mining machines that we want is the high annual capacity. It should have high annual capacity, the lower per ton reclamation cost, higher coal recovery, lower total coal production cost, and minimal out of the seam as dissolution. Now we have another category of mining machines, which we call it as a quarry mining machines. So what basically is a quarry? Let us first try to understand that. A quarry is a place or a cavern or a pit where stone is taken from the rock or dug from the earth for building or other purposes. So if you see here, this is how a quarry mines looks like, where we have number of boulders, where this kind of boulders are machined for building purposes. Now the examples of such mines are the limestone, dolomite, marble, granite, and other such stones which are used for building purposes. Now in quarry mining operations, smaller surface mining machines are particularly engaged in excavation of building material, road stones, and dimensional stones. So the process involves blasting of the rock mass, excavating and loading the broken mass to transport to a crushing plant where the product is crushed and sized to different customers like granite or marble quarries. So these machines are low capacity excavators, dozers, different types of crushing, screening systems like mobile jaw crusher, vertical impact crusher, stone cutting machines, stone sawing machines, etc. Now, there are also auxiliary operation mining machines, which we have already discussed. Like it involves a numerous construction operation and civil works, like building roads and culverters, workshop, drainage system, power supply, etc. Now, what are these? Like we have site preparation equipment like dozers, scrapers, or harvesters. We have road building machineries like motor graders or compactors. So you can see here we have a compactor here, which we call it as a road roller. We have material handling machinery like forklifters, cranes, drainage machineries, that is the pumps, and electrical equipments like transformers and lighting equipments. So the last class of machinery we see in the processing plants, so which we call it as a processing plant machinery, where there are various operation involved, from finally feeding the blasted out rock or the excavated out rock to the final shape that can be used by the consumer. So here you can see here the in-pit, this is a in-pit crusher where you can see the excavation takes place and immediately the material is fed into the jaw crusher, where it is again processed to the final shape that can be used by the consumer. Or it can be taken to a crushing plant where we have a vertical shaft impactor which should crush the material into different sizes of our need. So here you can see there are various operation in the processing plant which which are used for processing of the ore that is taken while the excavation. So with this we come to the end of this first topic of module 1, that is the overview on mining machines. So here there are certain books that I would suggest you should refer during the whole course. We would be following the first and second book for the tutorials. You can use the third, fourth and fifth book as reference material. And I thank you all for listening to this lecture, and I hope it is beneficial in your undergraduate or postgraduate studies. Thank you.